let's solve another example. We're going to try, like always, factorize two variables if this is possible. First term has a and c naught, right? I'm going to factorize these two variables with this term because this term has also a and c naught. Second term has a naught and b. I have another term which has a naught and b over here. These two terms have b naught c. I'm going to factorize b naught c from these two terms, and this term and this term have bc. So I have a c naught, and inside of the parentheses I'm going to have b naught or b, or from these two terms I'm going to factorize a naught b, and inside of parentheses I'm going to have c naught or c. From these two terms I'm going to factorize b naught c, and inside of the parentheses I'm going to have a naught or a. From these two terms I'm going to factorize bc. Inside of the parentheses I'm going to have a naught or a. Remember, two complements odd together are going to give me always 1. That's why I'm going to have a c naught and 1, or a naught b and 1. Remember that multiplication is nothing else, just and, or b naught c and 1, or bc and 1. A c naught times 1 is always a c naught. The same story is going to happen with a naught b or b naught c or bc. Next, I can factorize from these two terms c. I'm going to have a c naught or a naught b, or factorize c from these two terms, and inside of the parentheses I'm going to have b naught or b, and I'm going to end up with a c naught or a naught b or c. Now I can apply complement absorption theorem to these two terms. Complement absorption theorem says anytime we have complements and one of them is ended with something else, in this case we have a, that complement can be dropped out. That's why I'm going to cross this out. And I have a or a naught b or c. Again, I have complement absorption. A naught can be cancelled out, and my answer is a or b or c.